All right, last new lesson in this unit, solving quadratic inequalities. Plus we got a little review at the end because there is no review day in this unit, so we're just going to kind of tackle it today because we just got one simple little thing. We've got a quadratic right here, but see today it's an inequality as opposed to an equation. There's lots of ways to solve quadratic inequalities. The way I like to do it is called graph and squiggle. We're going to make a little rough sketch of this guy by factoring this guy, and then I'll show you what the old school part is about as we dive in. So first let's talk about factoring this guy. To see how there's three terms and the a value is 1, we're kind of got two choices here. It's like, is it an easy factor situation or is it a complete square, which isn't factoring, you know, I guess I can correct myself. But since the a value is 1, I'm going to try easy factoring. Can I find two numbers that multiply together to be a negative 12? But at the same time add together to be a negative 4. So since this guy's negative, that means out of the two numbers that I'm looking for, one of them has to be negative. So 1 and 12, if the 12 was negative or the 1 was negative, those don't add up. 2 and 6, there we go. If the 6 is negative, I think we're in good shape right here. So this guy right here factors to be x plus 2 times x minus 6, and we're going to bring the less than 0 down also. It's not an equal to this time. Well, we can find the zeros of this guy, which I usually call the roots. Like the roots, the zeros, the solutions, they all mean the same thing. The roots of this guy is just like how we solve the equations. It's like what value of x makes this 0, negative 2 makes this group 0, and 6 makes that guy 0. Well, here's what that means. The roots, the solutions are all the x-intercepts of this graph. So I'm going to just kind of make a rough sketch of an x-intercept of negative 2 and an x-intercept of 6 to see that those are the x-intercepts. And noticing a little purple note card concept that this parabola, since the a value is positive, opens up, I'm just going to make a rough sketch. Like, this isn't the most accurate thing in the world. It's got a vertex somewhere. The vertex has nothing to do with this, but this parabola opens up, and it goes through the x-axis at these 2 points. So out of the graph and squiggle process, there's phase 1. Make a little graph of this where the x-intercepts are. Now, the squiggle part has to do with what this says. This says they want to know where this thing is less than 0. Well, this is kind of like the y position if we was graphing stuff. And you know, the y position is like the y-axis, and they want to know where that's less than 0. Well, check it out. If you was to start putting a scale on this y-axis, would you believe that 1, 2, 3, all these numbers above the x-axis are positive y values, and all the numbers down here below the x-axis are negative? They want to know, hey, where is this graph less than 0 at? Well, that's when you're below the x-axis. So I'm going to kind of get rid of those little guys for a second. And below the x-axis, if I was to squiggle this parabola, like where this guy is below the x-axis, would you believe this purple zone right here is where this dude is below the x-axis? Well, now what we got to do is read this squiggle zone from left to right, very similar to how we read domain from left to right of where is my, I'm just going to call this blue line right here, where is this thing touching the squiggle zone? So if I drag it this way, it's not touching, not touching, not touching. There's where we start touching at the negative 2 position. So we're going to list it in interval notation. Negative 2 is the interval that it starts at, and we've got to go up and read this symbol to see if I need a bracket or a parenthesis. Since there is no equal to bar, I'm going to use a parenthesis. And then as I move to the right, moving it, touching the squiggle zone. Yep, I'm touching the squiggle zone, touching, 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 touching. And then once I get over here, it's no longer touching the squiggle zone. So that's at 6. And again, it looks tempting to want to put a bracket because I have a closed dot at 6. It's not about this being a closed dot or an open dot. It's about what this symbol says, and that doesn't have an equal to bar. So between negative 2 and 6, if I put those x values in here, that's going to make this group 0 in that case. So here's our answer, just the way we're going to put it, just in interval notation. Let's try that again. A little graph and squiggle technique. Let's see if this guy can easy factor. The a value has to be 1. There's 3 terms. You know, it's not a difference of squares because difference of squares has 2 terms. It's not a GCF because GCFs for us have 2 terms. So I want to see if I can find two numbers that multiply together to be negative 10 and add together to be a positive 3. And that means one of the numbers has to be negative. So check it out. If I was to go with a negative 2 and a positive 5, That's going to be a winner, winner, winner. So I will factor this guy to be like so. Bring my little less than or equal to 0 coming on down. And now I can find the roots. The roots are the x-intercepts. And that's going to be whoever makes this group 0, which is 2, and whoever makes that group 0, which is negative 5. So I'm going to plot those two dudes. Here's a 2, here's a negative 5. And this graph is going to make a parabola that opens up. So I'm going to just make a little rough sketch of a parabola. Kind of missed there a little bit, so I'll do a little bit of job. There we go. Want to go through those x-intercepts. And that's the graph portion. I don't care where that vertex is. We don't need the vertex for this. We're not asking for a maximum or a minimum. That was the graph portion. Now let's squiggle. It's a less than symbol, even though it does have an equal to bar. Less than means let's go below the x-axis. That's where the y values are less. So I'm going to squiggle less than, and that would be this zone right here. And I'm going to now do my little straight edge test with this guy. That's not going to move because I froze it, so I'll just put a new one here. I'm going to do my little straight edge test. And where, oh where, is this straight edge touching the purple zone? Well, if I put it way over here at negative infinity, it doesn't touch. Not touching, not touching, not touching. There's where we're going to start touching, right at that zone at 2. Is he included or not included? Well, this symbol says, yes, sir, you are included. And then let's move this guy to the right further. Touching, 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 touching. So that's in the interval, and it stops over here. I guess I miscalculated. That's not at 2. I couldn't read my own handwriting. It's at negative 5. Thank you for noticing that. I'm sure you've found my mistake. So that was at negative 5, and now we're going to go all the way over to 2, and he is also included because this symbol has an equal to bar. If I keep moving to the right, no touchy. It's not touching the purple zone, not touching the purple zone. So it's just one squiggle interval, one interval for our answer right there in that case. So graph and squiggle for quadratic inequalities. Let's try another one. Here's a quadratic inequality. Let's see if we can easy factor it. A values 1. Can I find two numbers that multiply together to be a positive 12, but add together to be a negative? When he's positive and that guy's negative, that means both these numbers have to be negative because a negative times a negative will be positive, and they'll add up to be some sort of negative. So 1 and 12, but they both have to be negative, that's not a winner. They don't add up to be negative 8. 2 and 6, if they were both negative, winner, winner, winner. There we go right here. So we'll factor him to be x minus 2 times x minus 6. Bring your symbols down with your 0. And then we'll find the roots. The roots are quite simply who makes this 0, 2 and 6. So rough guessing, please put the 2 and the 6 on your number line. And the parabola, since the a value is positive, opens up. So bada boom, rough little sketch. And now let's check out the squiggle zone. The squiggle zone, we have to follow what this symbol says. It says greater than 0. I know it's got equal to bar, but greater than. That's above the old x-axis. So that means I got to squiggle all of this above, and that's going to go on like forever, and squiggle over here. See, that's like two different squiggle zones as compared to back here where there was just one zone squiggled. Now we got two. So two squiggle zones mean we'll have two different intervals. Let's read from left to right of where those squiggle zones touch this blue line because we're talking about our x values. So remember, this, even though it gets higher and higher and higher, continues moving to the left. So if I start way over here at negative infinity, yes, that will eventually run into that blue thing, so negative infinity counts. Don't forget you get a parenthesis with that at all times. Infinities always get parentheses. And as I move to the right, this thing is touching the squiggle zone still touching, still touching, still touching, still touching. It's going to stop at that critical point of 2. 2 is where we run out of purple squiggle. The question is, included or not included? It's about the symbol on this dude, and 2 is included. Then, if I keep moving, you see there's this gap right here. I can keep moving to this. It's not, the blue line isn't touching the squiggle zone, but it is going to start back over again here at 6. So I bridge the gap with the union symbol, and I start at 6, which is included because of that symbol, and that's going to keep going on forever and ever and ever as I move to the right. It's going to touch a squiggle zone, touch a squiggle zone, touch a squiggle zone, because that keeps going on forever. So we're going to positive infinity on that. Don't forget, we always get parentheses. Two squiggle zones, two different intervals with a union symbol right there. So that's pretty cool. Let's try another one. Hey, I got a typo on this guy. This typo right here is supposed to be a negative 6x. So sorry about that. We're changing that to negative 6x. And here we go. So let's easy factor this guy. So sorry for the typo. Let's see if we can easy factor. Can I find two numbers that multiply together to be 5 and at the same time add together to be a negative 6? Well, since this is positive, both the signs have to be the same. And if they were both like a negative 1 and a negative 5, doesn't that work right there for us? So there we go. We get us a x minus 1 times a x minus 5 less than 0 in that case. So I will find my roots, which is the same thing as the solutions, which is the x-intercepts. 1 and 5 make these 0, and I will graph those. Put the 1, put the 5. Parabola opens up, so bada boom. And where to squiggle? Let this tell you. It says less than 0. Less than 0 is below the x-axis. That's where all these y values are less than 0. One squiggle zone, one interval. Reading from left to right, the squiggle zone starts right here. 1, is he included or not included? Right here. That says no thank you, not included. And squiggle, 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 touching, 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 touching to 5, also not included. So really cool there. Sorry for the typo, guys. We'll get that fixed. And then let's try this guy. Ooh, looky here. Only 2 terms. So it's either like a difference of squares or a GCF situation. Let's see what happens here. This is a subtract sign, so that's cool for difference. Is x squared a perfect square? Yes, he is. Is 9 a perfect square? Yes, he is. So this is a difference of squares. That will factor to be conjugates of the square roots. So it's the square root of the first guy and the square root of the last guy. And conjugates means one of them's a plus, one of them's a minus. This is all good for our little review day thing here too, to realize, okay, yeah, that's how you do a difference of squares again. Let's find them roots. The roots are, who makes this 0? Negative 3 and positive 3. So plotting those guys, negative 3 about right meow, positive 3 about right meow, and I will graph me a parabola. And it opened up due to that a value being positive. This sign is a greater than, so when it comes to squiggling, I need to squiggle above the y-axis, so doodly 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 doo. And also over here, 2 different squiggle zones, 2 different intervals, reading from left to right. If I put my cool little dude right here, will that purple squiggle run into this guy over here at negative infinity for a boundary? He sure will, because that thing keeps moving to the left and to the left, to the left. So from negative infinity, touching, 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 all the way to negative 3. So I'll start writing that down, negative infinity to negative 3. Is negative 3 included or not included? Not included. There is a gap when I keep moving over to the right, so to bridge the gap we will use that union symbol. And he starts over again at 3, not included, and he goes all the way over to infinity. So union, come on pen, union 3, not included, to infinity. 2 different squiggle zones, 2 different intervals. Solving quadratic inequalities. This is one method that I like to use. I think it's the easiest. It's the graph and squiggle thing. So last one of these, hey bro, only 2 terms, not an easy factor. Check it out. You know, it's like we got a 4 in that case. But you notice this is not a difference of squares. Even though this is a difference, and 4x squared is a perfect square, 8's not a perfect square, and neither is x, you know. So that's out. So it's just a GCF scenario. So between the numbers, I can factor out a 4. Remember the reverse distributive property. And out of this, as an x squared and an x, I can take an x out. And let's undistribute that. So dividing, 4 divided by 4 is 1. I'm not going to write it. X squared divided by x is x. Mr. Minus sign comes down. 8 divided by 4 is 2. And x divided by x cancel each other out to be 1. So that being factored like so. Bring my less than 0 down. And now it's time to find the roots. Don't let this guy fool us. He's so easy that he's hard. What value of x is going to make this 0? It's 4 times what? It's not like 4 plus x. It's 4 times x. So that root is 0, baby. And the other root, since there's a subtraction sign, or sometimes it's addition, that's where you do the adding thing. It's what minus 2 makes this 0? Well, that would be 2. So 0 and 2 are our roots, the x-intercepts. graph my parabola. He opens up. So newt, 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 newt. And I want to know where this guy is less than 0. So that would be shading below. We'll do a little squiggle. I said shade, but I want to squiggle it. 1 squiggle zone, 1 interval. Reading from left to right, no touchy, no touchy, no touchy, no touchy, no touchy. There we go. We start touching right there at 0, not included. And then it goes touch, 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 all the way to 2, not included. So yeah, that's it for the new stuff. Now let's do some review. Remember, no review day this chapter, so it's a good little refresher. Your homework will have lots of review problems on it. In the following problems, let X stand for time in seconds and Y stand for height in feet. A ball was in the air and followed by the path of this. What is the initial height? Don't forget that the initial height is the y-intercept. That's when you let x equal 0. So if you let x equal 0, this would turn out to be nothing. This would turn out to be nothing, and wouldn't you get 6 back? So 6, we want a label on that. So that is the height in feet. So we are in feet on that guy. So just that number right there, sorry, that's an eraser, but this number right here is our y-intercept. How long until the ball reaches its max height? Well, don't forget, this is a parabola that opens down. Isn't the maximum point of that parabola right here at the vertex? So we will find the vertex. Question is this in standard form or vertex form? Well, since there's not that cool little parenthesis thingy-mobobber, this is in standard form. To find that, we'll do x equals the opposite of b over 2 times a. And that would be a negative 64 over a negative 32. And that divides out. We can punch that in if we need to. That'll divide out to be a positive for sure. I got 2 when I divided that out. So that is the x value, and x stands for time in seconds. So that is the answer to this question, 2 seconds. What was the maximum height? Well, that's where we got to find the y value of the vertex. So we will put 2 in this equation. So we'll sub them in to parentheses. So negative 16, boom, times 2. Don't forget that little guy's got to get squared, plus 64 times 2 plus 6. And 70 is what I got. So 70 feet is the max height of that ball. How long until the ball hit the ground? Well, we've got all kinds of ways to solve this quadratic. That's when we're going to let 0 equal this guy. And, you know, we could try to factor this. We could try to complete the square on this guy. But this is a perfect quadratic formula. You know, it's like we don't want to do the old complete the square because a is not 1, even though b is even. So I forgot my x there. But this is totally a quadratic formula because it would be the easiest way to do it. So I'm going to recognize a, b, and c, and then I will put those in. A is negative 16, b is 64, and c is 6. So quadratic formula, opposite of b, plus or minus the square root of b squared. I'm going to go ahead and figure that out ahead of time. 64 squared. Remember, that's always going to be a positive number, so that's 4,096 minus 4 times a times c all over 2 times a. Now we get to find that discriminant, so that's this cool number underneath here. So I'm going to do that all in my calculator. Don't put the radical around it. Remember, we're just going to do the 4,096 minus, and just punch that in, negative 16 times, what was it, 6. Make sure I punched it in right. And I got 4192, so cool, cool, cool. Negative 64 plus or minus the square root of 4192 all over negative 32. And now I just got to punch that in. So we'll do that. I'm going to do negative 64 plus the square root of 4192. Boy, I hope that was the right number. Hit equals, and then divide by negative 32. And I'll write that guy down, about negative 0.02 seconds. And then I'll do the minus version of that guy, negative 64 minus the square root of 4192. Hit equals, divided by negative 32. and we get about 4.02 seconds. And we got to throw out Mr. Negative guy because that makes no sense. So it was approximate because we rounded. About 4.02 seconds is how long it took for that ball to hit the ground. So cool, that was a good review. Here's another one. Write the equation in vertex form, then graph it. So don't forget, no review day. We're just kind of going over this. To put it in vertex form, you need 3 ingredients. You need A, H, and K. So I got none of those. They didn't give me ordered pairs or anything. They gave me an equation in standard form. So I need to find A, I need to find H, I need to find K. A is that freebie. A lot of people miss that. It's like, what the heck is A? It's right here. It's the number in front of x squared, so that is 1 in this case. H, we find the x value of the vertex by doing opposite of B over 2 times A, and that would be negative 2 over 2, which is a negative 1. And then we will substitute that negative guy in using parentheses. So put negative 1 in parentheses squared plus 2 times negative 1 and then plus 7. And I got 6 for the y value of that vertex. So I'm going to put that right here just for the time being, negative 1, 6. And I'm going to write this homeboy in vertex form. Y equals A, which they told us, 1. You don't have to put it if you don't want to, since it's a 1, times the quantity of x minus a minus 1, so that's x plus 1. Remember, that's crazy opposite game, squared. And then K is what you see is what you get. We have been punching these guys in to graph both of them at the same time. I'm going to pause real quick and do that. Well, if I can, I got to find my little button. There she is. So I went ahead and did that on my own time here, paused and put these in, and then I'm going to zoom 6 it, see if I get the same thing back. That tells me that I did my algebra right, and yes sirree Bob, they landed right on top of each other, if you can see that. Sorry, it was very small, but they landed right on top of each other. So I want to graph it by going to my cool graphing calculator and going to the table, and we're starting at the vertex of negative 1, 6, and then I got 0, 7, and 1, 10, and that's about all I can do. So 0 and 1, negative 2 and negative 3. So 0, 7, and 1, 10 is what it said. That means symmetrically this is going to happen also, and I shall plot those. Negative 1, 6, meow, 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 meow. 0, 7, bada boom, 1, 10, burr, 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 burr. And plot those. And that matches just what our little graphing calculator looked like as well. So, where is the vertex? Negative 1, 6. Don't get fooled on that. You know, remember, it's opposite game. Axis of symmetry, we'll draw it in with a straight edge. So we'll just go, it's the vertical line that goes right through that vertex. So boom, don't forget to put arrows on it, of course, because it's a line that goes on forever. And it is x equals whatever that x value of the vertex is. And the direction of the opening, bro, that's up. Nice. Couple more complete the square problems just because we need a little more practice with it. So notice that A is 1 and B is even, but I cannot factor due to the fact that I can't find 2 numbers to multiply. It's got to be this and that's got to be that. So we'll set them up with blanks. That's going to be x squared minus 4x with a plus blank equals, got to get this homeboy over, 7 plus blank. How the heck did we fill in that blank? Half the b value squared. So that would be negative 2 squared, which is 4. That goes on both sides. Then this old boy right here, he factors to be square root of the first guy, boom. Square root of the last guy, boom. Sign from the middle. Do arithmetic over here and add those up. And now that you got a quantity squared all by itself on one side of the equal sign, you can square root both sides to get that done. You will need a plus or minus. Then we just get x all by itself by adding this dude over, or so if we're doing the opposite to move him over, right? It's not always adding, so it depends on what that was. And there she goes. So let's do one more of those. X squared plus 4x plus blank equals, move that over, negative 5 plus blank, and then fill in the blank. Half the b value squared. 4. That would be x plus 2 quantity squared, square root of this guy, square root of that guy, sign from the middle, add these up. Oh no! Negative. That means we're going to get some imaginary answers when we square root both sides. So rock and roll. Don't forget your plus or minus, and the square root of -1 is I in that case. Then we shall subtract that dude over and get -2 plus or minus I. Cool. Last thing is some multiple choice. You'll see these on the test as well. So choose the best method to solve. Is it a GCF? Is it a difference of squares? Is it easy factoring? Is it complete the square? Or would you use the quadratic formula on this guy? So when there's two terms involved, it's really these two guys, right? It can't be any of the, well, I mean, you can always do the quadratic formula. It might not be the best way to do it. So is this a plain Jane GCF, or is he a difference of squares? Well, to be a difference of squares, this has to be a subtract. This has to be a perfect square. Yep, 25x squared is a perfect square. And so is 9. So boom, that is a difference of squares, which is option B as in boy. This guy cannot be the difference of squares because it's got 3 terms. He's not a GCF either because there's just like not a number that goes into all 3 terms. So it's either easy, complete the square, or quadratic formula. First, let's see if it's easy. A value's got to be 1. Boom, that's happening. Can you find 2 numbers that multiply together to be a positive 9, but add together to be a negative 6? So they'd both have to be negative. So -1, -9, that don't work. -3 and -3, that does work, right? That totally works. So isn't this an easy factor situation? That's choice C. If you chose complete the square, it's not a bad method because you're like, well, A is 1 and B is even, but you could factor this. That's even easier in that case. And how about this guy? It can't be a GCF or a difference of squares because 3 terms. Easy factor is A1, yes. There are 2 numbers that multiply together to be -15 and add together to be -3. So 1 and 15, but one of them is negative. Nope, so one of them is negative, but still that's not going to work. 2 doesn't go in there. 3 goes into 15 5 times. If one of those was negative, is that going to add up to this? Nope. So I can't easy factor it because I can't find those 2 numbers that do that. Is it complete the square? A's got to be 1. Check. B's got to be even. Nope. So that means we're going quadratic formula on this guy. So rock and roll. This is the last assignment in the old unit right here. No review day next time, so your homework has plenty of review. Come see us if you have any questions, and thanks.